Hey everyone, I'm Niall O'Higgins. I run the SRE team at Coinbase.
My name's Daniel. I'm a developer advocate with Datadog, and we are up here today to tell you about
building SRE from scratch at Coinbase during Hypergrowth.
Fantastic. That worked out just as we planned. Choreographed.
All right. So I'm going to start by asking the question, why do we even care about SRE at Coinbase? And it all comes back to what our CEO, Brian Armstrong, said, that our goal is to make Coinbase the most trusted cryptocurrency platform in the world. And to be the most trusted, you really also need to be reliable. And we found that, and sometimes in the past we hadn't quite been as reliable as we wanted to be, and we were concerned with eroding customer trust. And so the why for us with reliability for SRE is that in order to be the most trusted, you have to be the most reliable.
It's good to have a vision, right? To know why you're embarking on a program like this. It's a big shift for any company. It's a big undertaking, and it's something we're going to be explaining as we move forward. And at every point along that journey, from start to end, you want to be able to have that North Star to point at, to go, why are we doing this, right? A simple explanation to a complex question.
So we've talked a little bit about the why, set the stage with that, but what is SRE? I get asked all the time, what is SRE? And the truth is, definitions really vary. It's a new field. There are a lot of misconceptions.
That's absolutely true. Well, to quote Ben Traynor, actually, who he founded, actually, a well-known SRE team back in the day. SRE is what happens when a software engineer is tasked with what used to be called operations. Okay, that's a simplistic definition, and we're going to go into why that is, but it's a good starting point. All right, it assumes some terminology and things, but it's a good place to start. And one of the themes that we have going through this entire presentation is you have to start somewhere. So let's start with that. But talking about those misconceptions for a little bit.
Yeah, for example, which of these things are SRE? These are things that people are always bringing up when I'm talking to them about SRE. So is SRE about endless firefighting? Is it about punishing on-call rotations and terrible pager duties? Or is it about staying up all night in a data center, pulling hard disks out of server racks, and engaging in operational toil? Well, I don't think so. I really don't think so. I would say that if you have to deal with these things, these are actually the symptoms, and SRE is the cure. So there is a connection there where SREs are often brought in to help with some of these issues, but really SRE is the cure for these things. And if you're suffering from these ailments, maybe you should think about having SRE as well.
Now, to be fair and to be completely transparent, embarking on a program of SRE isn't going to eliminate firefighting and eliminate on-call rotations and eliminate the need to rack servers and data centers. The idea here is just to sort of deal with the pain there, right? To make that less onerous. Would you say?
Totally.
Absolutely. All right, before we go any further, I do want to address the elephant in the room. And the elephant in the room in IT is DevOps. Always DevOps. There's a well-known SRE book with a fun quote, which is that SRE is a specific implementation of DevOps with some idiosyncratic extensions. Now, this isn't necessarily a talk about DevOps, but if you're familiar with the CAMs or the CALMs, with the automation and the measuring and the sharing and so on and so forth, a lot of what we're going to be talking about here in this presentation rings true, okay? The takeaway from this is that DevOps and SRE actually work really nicely together. So if you're doing the DevOps, SRE is going to be a good fit for you. But today we're going to be talking about SRE specifically. That's the last time I'm going to say that word.
All right, so now that we know the why of SRE and the what, and I've kind of said that it's something new, well, what are the key insights of SRE? What are the main takeaways about SRE? And I think there are three, and we're gonna go through three here in this presentation. So the first key insight of SRE is that it's not just about measuring and instrumenting machine systems. So as engineers, we tend to think about the reliability of our systems, our software, our hardware. But what about our human and organizational systems? Well, we need to measure and instrument those. And we need to inspect the health of those things. So, for example, if you have an incident, what's your response process like? Are you following up with improvements? Are you learning from these things? Are your human systems getting better? Or are you just focusing on machine instruments? So that's the first key insight, is to measure machine systems, but also human and organizational processes as well.
SRE is absolutely tied into sort of the human side of doing business, and indeed the business side itself. And we're going to be going through that. But again, the takeaway here is measure everything, always.
Right. So the next key insight, in my opinion, is SRE is about going from a reactive mode to a proactive mode in terms of reliability. So you don't want to wait until your house is on fire and then you call the fire brigade. Instead, you'd rather install smoke detectors. So you want to get proactive about measuring reliability, about thinking about it. And the other thing you want to do is you want to actively look for operational toil, and you want to go out and eliminate that before it becomes too big a problem. So the second key insight, move from reactive to proactive. That's really important in SRE.
Super important. And before we move to the next slide, you mentioned the word toil a few times already. For the benefit of the audience, what is toil?
So toil can be defined as manual operational work that doesn't scale. So as the organization grows, there's just going to be more and more of it.
So I guess you could say that toil is what we have to do, and as the organization gets bigger, there's always going to be more of it. The problem is that people can't scale to meet it.
Exactly.
All right, SRE can address that problem.
All right, the third key insight of SRE is to provide an organizational feedback mechanism. So this is one of the key roles of SRE within the organization. What does that mean when I talk about an organizational feedback mechanism?
It's a good question.
Yeah, so I'll tell you what I think it means. I think that it means that you want to be able to objectively measure your reliability. It can be difficult to objectively measure that. And if you objectively notice that your reliability is decreasing in some area within the organization, you want to have the capability to move resources and reallocate them to improving that reliability. So say, for example, you might need to do things like, okay, we're going to delay this feature, and instead we're going to work on cleaning up tech debt or improving database performance or something like that. You might even go so far as to stop deploys altogether. You might say, reliability has been so poor, we're actually not going to deploy any new software until we figure this out. So that's what I'm talking about when I mean the feedback mechanism within the organization. That's a really important role that SRE has to play.
Communication. Really just big focus on communication.
Exactly.
For sure. So to do all those things, right, to actually stop feature production, to actually not roll out any new deploys, to actually have the ability to take on these sort of large-scale tasks and make these sort of large-scale decisions, you need buy-in, right? You need buy-in. You need it both top-down and, of course, bottom-up, although the former is going to be more important because you need to get your C-levels on board. And that's where having a vision, right? The why that we discussed earlier is so key. You need to be able to get people on board with that argument.
Yeah, when you start SRE, when you decide to embark on this journey, you need to set some early expectations. So just being honest here, like SRE is hard. There's a lot of new concepts, a whole new language. Some of the ideas, we'll talk about them a little bit, but they're really quite profound, and they take time for people and the organization to absorb. So don't expect instant results. It's going to take time, but as Dan said, you got to start somewhere. So let's begin.
All right. Well, where do you start?
So I can tell you about the strategy we used at Coinbase, and which maybe you might want to use yourselves, or you can learn from it. So the question is, where do you start? The way we thought about it was, how do we improve reliability if we don't know how and where we're reliable today? So this is the basic idea of, if you want to improve something, first you need to measure and understand it. So what we did is we started with instrumentation. And we started implementing service level indicators throughout our entire system. And the other thing is, well, okay, we want to instrument all of our systems. That feels overwhelming. There's so many different things that we should measure. How do you narrow that set? How do you prioritize the things that you're going to work on? we use the framework of the 4 golden signals, which we think is super helpful. We'll talk about that a little bit more.
Well, we are going to get into those 4 golden signals in a little bit, but for now, we'll stay on track. Let's talk about metrics, right? The core of SLIs. We'll talk about metrics. Real talk. We, as technical people, have a tendency to over-engineer everything all the time, all right? It doesn't have to be a bad thing, okay? But it's important to be aware of this sort of natural tendency, this propensity we have to do this, because it lends itself to things like vanity metrics and dashboards full of numbers that look good, but that don't actually tell us anything interesting. They don't actually give us a story that we can use to move our business forward. What's important is to really spend time, to really dig into the numbers that matter, right? The key performance indicators, or KPIs, that represent the success or failure of your operational, strategic, and business goals, right? These are the numbers that you want to concentrate on, and it takes time and effort and experience, sometimes even just to figure them out.
That's right. So it's very easy to overwhelm yourself with all sorts of different machine metrics and so on and so forth. But, and you'll just overwhelm yourself. Like I said, you'll have all of these time series graphs that really don't tell you anything. So where do you prioritize? And the framework that we use, and that I think is a wonderful framework for others to adopt, is the 4 golden signals. So these indicators apply to almost every service. They're pretty universal. In fact, they even apply to humans and teams and organizations, which we'll talk about a little bit. But once you adopt these things, you have a common framework and a common language that people will start talking about, and you can instrument both human and machine systems with them.
Well, instrumenting human systems sounds a little bit dystopian, frankly, but I assure you that it's not, at least not in the way that we're going to be describing it, as we'll see a little bit later on. So let's actually talk about the 4 golden signals a little bit. In no particular order, the first one we're going to mention is latency. So the classic example of latency is how long it takes for a web browser, for example, to get a response from a web server, right? But that's not the whole story. Latency has a direct impact on customer experience, right? If the response is too slow, your customer is not going to be happy. They're going to leave the website. I mean, that sucks. They get upset. So the question is, why is it slow? Right? And that's a big question because it basically depends on how you measure it.
Yeah, that's right. So latency is a fairly simple idea, but when you get into actually implementing the indicator for latency, one of the questions is, well, where do you look at latency? Where do you instrument it? There's a lot of different options. So do you instrument it at the load balancer, in the client to get the full round trip? Do you instrument it in your server code? There's a lot of different options there, so that's kind of some of the complexity to actually implementing these golden signals.
But you could put it in all 3. That'd be pretty sweet.
That would be pretty sweet.
Yeah, that would be pretty sweet. So anyways, this is why latency is one of the 4 golden signals, right? It's primordial to every exchange, to every interaction that your systems have, that you have with your customers. You need to be thinking about this, and you need to be concentrating on this as a metric, a prime metric, right?
Yeah, so next we have traffic. And I think about traffic as the total volume of work or volume of work being attempted at a given moment in time. So you might measure this, like a typical measurement is transactions per second. That's a very common way of thinking about traffic. And the other interesting thing about traffic is we often know for our services and our software that there's some threshold in terms of traffic beyond which behavior becomes, let's say, undefined.
It's kind of like the horizon of a black hole, right? I mean, who knows what happens after that?
Yeah, don't know. So traffic has this threshold, and things get undefined after that, right? Like, you might have data written out of order, requests dropped on the floor, all this type of stuff. But that's one of the interesting things about traffic. So it's one of the key 4 golden signals.
It's not just about engineering, though, right? Traffic often maps to business volume, right? There's generally a relationship between traffic and volume, what your business is actually doing. And therefore, it has a direct relationship to business value, right? So again, here, this is why it's one of the 4 golden signals, one of those metrics that you need to be acutely aware of, that everyone across the organization needs to be on top of.
Another of the four golden signals is errors. Error is an interesting one. It's usually expressed as a ratio. So you take the ratio between the number of failed requests and the number of successful requests. And having a ratio is really nice because you get a percentage. And when you have a percentage, you can easily set a target over that percentage. So you might say, for example, I don't know, yesterday was Cyber Monday. And so what was the error rate on some of these transactions where there were news stories about people being unable to buy stuff? Maybe it was 50% error rate for some of these situations. But your target, it's going to be pretty low, right? Maybe your target error rate is something like 0.1%, something like that. So that's the really nice thing about errors. You can express it as a percentage, and that lets you easily set a target.
What's nice about that, too, is that it's an easily digestible number. Right? It's something that anybody in the organization can look at and immediately know what it means and have an idea of the impact of that. And that's why it's powerful. It's a powerful motivator, a powerful indicator. And like latency, it has a direct impact on customer experience. In any sufficiently complex system, however, errors are going to happen. Right? I mean, in any sufficiently complex system, they're going to happen. It's inevitable. So the goal here is not to eliminate errors. The goal is to identify what an acceptable error rate is. And then once you have that acceptable error rate, keeping it low becomes a primary business objective that, again, everybody can work towards.
Yeah, so the final signal here is maybe a little tricky. People often ask, what's the difference between traffic and saturation?
So what is the difference between traffic and saturation?
Great question. So the difference between saturation and traffic, you can think about, so traffic is the total volume of work being done or being attempted. And you can think of saturation as how close you are to your total available capacity. So some common examples you might think of with saturation are how much free memory is left in your application servers, or how much disk space is free on your database servers, things like that. Those can be a starting point for your saturation metric. So that's the difference between traffic and saturation.
So it's kind of like potential energy, right? If you come from an engineering background, for example. If there's none left, no more work can be done, no matter how much you want that to be true, right? And again, this is true across the board. At every level of the application stack, not just the software, not just the servers. Saturation is an issue everywhere at all times. And that's why, again, it's one of those four golden signals that you need to know about that an SRE program can help you to learn and, frankly, deal with.
So we've spent quite a lot of time talking about the four golden signals, and I think that's just because it's such a critical thing to understand. It's such a useful framework for understanding your reliability. And the interesting thing about it is it doesn't just apply to machine systems. This also applies to human systems. So you can think about things like, latency and traffic of teams.
Interestingly enough, explaining saturation in human terms is much easier than explaining it in technical terms, right? Saturation from a human perspective is burnout, right? And burnout's a big topic in our industry for good reason. A lot of people are suffering from it. A good SRE program is not just going to be looking at technical numbers, not just looking at the ability of our machines to continue to do work, but an SRE program is also going to look at our ability for the humans to do their jobs effectively. Right? An SRE program can track that. So we talk about burnout, and I really, really want to drive that home, that this is an important thing, an important metric to be gathering about your people as well, right? Latency could be, for example, how much time people are waiting on blockers, right, for other people or other business units to get their work done. And traffic is relatively straightforward as well. That could be described as just how many tickets are left in the queue for a customer success team to deal with. As for errors, let's be gentle here, right? Everyone makes mistakes. To err is human. The idea here is to just not make too many mistakes, I guess. And a good SRE program will also help people to make fewer mistakes. Okay, deep breath. That's a lot of heavy stuff, right? We've gone over a lot of pretty core principles there, and you kind of gotten into some psychology and some philosophy and whatnot. You can really go deep on it. And this is where I'd normally say something about the journey of 1,000 steps or something equally deep. But how about instead of a platitude, I give you a certitude. You can't finish something that you don't start. Remember I said one of the themes is you have to begin, right? You have to start somewhere. So if you're starting with the SRE program, you have to start with an initial specification, or in other words, your best guess. All right? It won't be perfect. It can't be perfect. You just need to start somewhere.
So we've talked about service level indicators, the 4 golden signals. How do you actually implement this at your organization? What tools do you need? Is it complicated? It doesn't have to be. Start with a spreadsheet. Spreadsheets aren't necessarily always simple, but they're pretty accessible. Everyone can use a spreadsheet. They're easy to share, easy to collaborate with, easy to understand. You can create one like this. You have 5 columns, one with the name of the service, and then one for each of the 4 golden signals. And then each team or service owner is responsible for adding a row for their service and describing how the 4 golden signals apply to their service. And so in this case, there's a couple of different things here. So say, for example, for service foo, the traffic indicator is transactions per second. And then saturation, for whatever reason, is disk space. But then what we've done is we've said, well, for error rate, we have this metric name, which in our case, it might be a link to that metric in Datadog. So you can just click on it and you can go see a time series for that metric. Similar for latency. You can just link directly from the spreadsheet, which is super useful. So when people talk about where do you start with all of this, start simple. Just start with a spreadsheet. Get service owners to populate that, and this builds a really strong foundation for reliability.
The nice part about the spreadsheet is everyone knows how to use it, right? At the end of the day, that's what you want. You don't want any barriers to entry in terms of gathering the information and getting people comfortable with that information. And a spreadsheet, as simplistic as it sounds, there's no magic here, is just the simplest way to do it.
So when you're going through this process of instrumenting everything, as I mentioned, you're starting out and you're trying to understand your reliability across all of your systems and services, and you're instrumenting the 4 golden signals, and you have your spreadsheet. How do you know when you're done? It's really helpful for engineers to, they see a JIRA ticket, implement the 4 golden signals or something. Well, what's the definition of done for the people working on this? So at Coinbase, the definition of done that we came up with was that we would have a per service dashboard in Datadog, which has a time series chart for each of the 4 golden signals. And then the second part of done is that you have a document actually describing these indicators. So it's not always obvious why you're using these indicators. Why are they important? Why should anyone care? How are they implemented? So those are the 2 features that you need to have in order to be done with your SLI phase.
So dashboards are your friend here, right? But be careful. Remember what I mentioned earlier about over-engineering things? You need to have just enough information, right? Sufficient information, but you don't want to have too much because that's going to complicate the issue. This is going to take time and effort to get right. You're going to start with something that has way too much stuff on it, and the pendulum will swing to the other side, and you're going to rip out all of the different metrics, and you have a dashboard that doesn't have enough information on it. That's okay. If you're iterating on it, the process is working as intended. All right? So actually, let's dive into these 2 points in order. So this is what 2 of the 4 golden signals might look like in Datadog, or indeed in pretty much any graphing application at the end of the day. There's a whole other presentation to be made on sort of the qualities of metrics and how to interpret them and what to do with them. But what's important here is that Coinbase started somewhere, and they started with the 4 golden signals and started tracking those as quickly as possible and basically got just immediate value from them, right? Start somewhere. This is a good place to start. But starting simple doesn't mean you have to stay simple, right? As you can see here on the error graph, it belies a certain complexity, right? Consumer bulk, write latency, Pioneer 5, that's fine. Having access to the metrics is necessary, but ultimately insufficient. You have to choose to ingest and manipulate and deal with those metrics in ways that make sense to you, to your use case, to your organization. So you need tooling, all right, that is going to make sense to you. Fair enough? All right.
So I talked a bit about like the importance of good specification docs for this, and I just want to go into a little bit more detail of what this should actually look like or could actually look like. So again, it's really critical when you're talking about the 4 golden signals and how you've instrumented them. So we talked about latency earlier. Let's say you're implementing latency indicators for your service. And ultimately what you want to be able to do is measure it in the client. So maybe you have a mobile application and you want to count end user, customer visible latency as your main indicator. But perhaps that's complicated to do. Maybe it's going to take a month or a few weeks or whatever to actually implement that in your mobile app. Well, you might decide that, hey, you know what, like Datadog and AWS, it's basically free to capture latency information for this service at the load balancer. It's just there. So today we have it captured and measured at the load balancer, but in 6 weeks we want to implement it in the client. And this is why the specification docs are so important, because you can talk about why this indicator matters, what it tells you, and also the future roadmap of it and what you're going to do with it in the future. So building a culture of SLI specification docs is really valuable when you're building reliability into your organization.
As an aside, we have a feature built in, and the reason we built this is because as, again, technical people, we're very, very good at writing documentation, and we always keep it up to date. Whoops, I actually meant the opposite of that. And one of the reasons why documentation doesn't get written and doesn't get kept up to date is, one, it's kind of boring, and two, there's often just friction in the tooling, right? Having a context switch out of the thing you're working on into a completely different tool or mechanism and then describe something outside of that mechanism, that's a barrier to entry, right? Context switching is very, very hard. So our solution was to actually just put the documentation directly into the product. Now, okay, fair enough, I'm a bit biased. I work for Datadog, so I'm pushing this a little bit. But at the end of the day, whatever solution that you choose to use, you need to have a tight coupling, a tight relationship between the documentation and the tooling itself, because that will reduce the barriers to entry, reduce the friction to actually keeping it up to date, and ensure in a crisis scenario that people have access to information immediately. Super, super critical.
Okay, so we've gotten through the SLI phase. We've written our specifications. We have Datadog dashboards for all our services. You've got an amazing foundation that you can build upon. And now you can start to think about promises. So you can go through an exercise with each of your teams and you can say, what are the things that you promise to your customers? And then what promises from other teams do you depend upon? And this can be a lengthy process. So this isn't going to happen overnight. But if you start asking these questions and thinking about it, you'll begin to discover some really interesting stuff.
Don't be afraid of bringing people on board during this process, all right? That's actually super, super important, especially if those people can help you understand things that you're not already an expert in. In fact, that's the most important part, right? A good PM, and pick your poison there, product, project, et cetera, but a good PM can help you answer questions that you didn't even know you had to ask. And we're talking about a good SRE program, we're talking about building one out. Again, we're talking about people, we're talking about machines, we're talking about business value. And it's important to have an holistic understanding of what it is you're trying to measure, what it is you're trying to improve. So get people on board. But the bigger question here still remains, why? Right? Like, why do all this stuff? SLIs and metrics and hundreds, if not thousands of hours of engineering time and business allocation and resources and stuff. Okay, it's a huge undertaking. Well, it turns out that there's a simple answer to this fairly complex question, and that is, this helps you keep your promises.
So when we think about promises, or you think about it, your company, your business, your team, what are the promises that you need to keep that really matter for you? I think for Coinbase, one of our most important promises that we make to our customers is you can rely on us to buy or sell crypto whenever you want. And I think about SRE at Coinbase then about helping us as an organization keep that promise to our customers. So that's kind of the key there, is really about maintaining promises to our customers.
So this right here is basically essential reading. All right? Name of the book is Thinking in Promises. The author is the esteemed Mark Burgess. You have to read this book. It's incredible. He's actually a fairly prolific writer. He's got a ton of material out in blog form and academic papers and so on and so forth. Some of Burgess's material is, let's go with dense as a descriptor. I think dense is a good descriptor. Thinking in Promises is approachable. All right? It's actually aimed at people like us, right? People in tech. It's full of actionable, solid content, and that's what makes this a really, really, really good starting point, not only for SRE programs, but frankly, just thinking about how you run your systems in general.
Yeah, like this promise theory idea, it's very deep. It's quite profound. There's an entire information systems theory called promise theory. You can go very, very deep on this. We're just going to scratch the surface in this talk.
Really just touch on the highlights, basically. Again, it goes super, super deep. So this right here, as you can see on the big screen, is the simplest possible way of thinking about promises.
That's right. So there's a couple of core properties. Promises can be human to human, human to machine, machine to machine. That's an interesting thing to realize. It's not just about machine systems. And then they have two parties. So you make a promise to someone, and then they can also depend on you for a promise in return. So they're bidirectional in that sense.
Both parties are components of the promise, but they don't necessarily have to have equal responsibilities. This is normal, right? This is fine. Promises can be made between any combination of human and machine, and it's important to think about the implications of those combinations. As technical people, and I've fallen into this trap myself, we might find it easier to imagine and reason about technical promises, right? Like you have a particular chunk of code that expects an API or a message queue to be there, and like that's simple to think about, right? But that's only part of the whole. This is where working with a cross-functional team, as I mentioned earlier, is really going to help. It's going to get you out of your comfort zone and into thinking about the rest of the business and the abstractions beyond the computer, right? Promises are statements, effectively, right? They have to be plain language, right? That's super, super important. Easy to understand conditions is also super critical. Did this or did this not happen, right? Did we or did we not fulfill this easy to grasp statement?
Yeah, I think these examples, they're very practical examples of promise theory in the real world that you can use in your organization today. So one thing to note here is that a couple of these promises are built on indicators that are part of the four golden signals. So you have your entire system instrumented with the four golden signals. Now you start to build promises on top. Here you can see some examples of those promises. So you can say, your service promises to respond to clients within 50 milliseconds. That's a promise built on top of the latency signal. The next one, maybe this is going the other way around. So a service you depend on promises you that its error rate will be below some threshold. So again, this is a promise in the opposite direction, and it's still built on one of the four golden signals. And then finally, don't forget that promises can also be about humans. So we might say that on-call engineers promise that they'll engage in an incident within 15 minutes. That's an example of a human-based promise.
So you can take these promises and implement them probably at your organization or some variation of them today. And that's actually the really, really cool thing about promises and promise theory is that once you have an understanding of what it is, it's actually relatively straightforward to implement. And you're going to get value out of it basically right away. It's actually quite revolutionary. Once you see it in action, it's a beautiful thing, frankly. So now that you understand a little bit about what a promise is, right, simple statement, conditions, so on and so forth, the question then becomes, how do you use them, right? How do you come up with your own promises?
Yeah, I mean, after you leave this talk, what can you start doing immediately around some of this stuff? Well, again, start simple. You can create a spreadsheet. Love spreadsheets for this kind of thing, where you work with each team, you enumerate the promises that those teams make, and the promises that they rely upon. And this will get you a central spreadsheet with all of this information, and it will start to expose some really interesting things, as we'll get into in a bit.
Well, there's those spreadsheets again, right?
Spreadsheet.
Keep it simple. The important thing here, and I do want to point this out, is that this sounds like work, and it is, right? It's simple to understand, but you do have to put in the time and the effort. The nice part about it is it doesn't have to be boring, it doesn't have to suck, right? You can actually turn this into sort of a fun activity for values of fun. Make a game day out of it, get people on board, get some pizzas, and actually think about critically how it is that you all work together, right? Just the exercise of doing that is beneficial, right? Cross-communication, getting teams on board, getting ready to talk to one another, just that alone, all right, whether you're doing an SRE program or not, is huge.
So similar to with service level indicators phase, when we're instrumenting everything to understand where to invest in reliability, how do we know when we're done with a promise? Well, for us, we said that done for a promise is that there exists in Datadog a monitor that generates an alert when that promise is broken. And so each team will enumerate their promises, build Datadog monitors for those.
So monitors in Datadog are actually pretty interesting. And before you laugh, I actually really mean that. We're well past the days of simple sort of min-max bounds or string checks, although of course those things still exist. You can set up monitors and alerts basically on just about anything, right? If it's measurable, you can alert on it. And you can actually put alerts on things that you might not even entirely understand yet, right? So things like anomaly and outlier detection and forecasting. In fact, that last one, forecasting, is super important. Whatever tooling that you're going with to help you embark on this program needs to have the ability to look back in time and to give you ideas about what's going to happen in the future. The powerful thing about anomaly detection and forecasting from a tooling perspective is that it's going to help you to know when a promise is at risk of being broken. Remember we were talking about toil, about endless firefighting. Don't wait for something to be broken in order to deal with it, right? Identify the things that are at risk of breaking, identify the risks of those broken promises, and treat them before they become a disaster. So, in my capacity as a semi-professional storyteller, I end up coming with a lot of these old sayings. And there's an old saying that goes, promises are meant to be broken. Some would suggest that that's a negative or nihilistic view on the nature of obligation, and they might be right. But when viewed through the lens of promise theory, it takes on sort of an interesting aspect. By planning for the inevitability of broken promises and for building out processes to deal with that inevitability, you get something super, super important and super, super valuable. Having the model, having the procedure, gives you confidence, all right? It builds trust, not only in yourself, but in your team and in the organization's ability to deal with what happens when the inevitable inevitably occurs.
And when you're thinking about promises that get broken, what is your incident response process like? Because ultimately, an incident probably occurs because some promise somewhere, articulated or not, has been broken. And so how do you respond to that? How do you have a feedback mechanism so that your incident response process actually improves over time? How do you learn continuously from these things? Those are things we'll talk about a little bit.
A continuous feedback cycle, though, that's super important, right?
Exactly.
Yeah, for sure. So a lot has been said about this, blameless post-mortems, both pro and con, up to and including whether such a thing can even exist. I'm here to tell you that yes, blameless post-mortems do exist, and yes, they do work. The issue, like so many things in the technical world, is one of naming, right? Naming things is hard. Okay? And maybe blameless postmortem wasn't the best name, ultimately, right? There's a fellow here that I actually put a URL, and you should check that out, so take a picture of this. His name's J. Paul Reed. He has an interesting take on this. He prefers to talk about blame-aware postmortems, which is, I think, actually a better name. And then we at Datadog actually have our own take on it, and that's the second URL there you should take a look at, where we call it data-driven post-mortem. So we take the word blame out of it entirely. Now that's, of course, its whole presentation as well. But the gist of it is that you let the data do the talking. Nonetheless, however it is you're dealing with the aftermath of disaster, because it's going to happen, you can't avoid it, right? Error, what's your acceptable error rate? It means an error is going to occur. What you need are three things, right, to actually analyze and deal with the outcome there. You need good instrumentation. And again, just pick some instrumentation, but it needs to be good, right? You also need a good understanding of what that instrumentation has measured. There's a subtle difference there, right? It's easy to measure a thing, but not understand what it is that you've measured. So you need to have a good understanding of the thing you're measuring. And finally, you need a process for interpreting and reasoning about those measurements. So that's the trifecta right there. They're all related, but you do need those three things. Without those three things, no post-mortem process will work, no matter what you call it. Okay?
So you have some incident response process, and you're using blameless post-mortems, and that's great. It's important to have a shared language around these things. So, often the biggest problem in an incident isn't actually the technical response. Maybe engineers are actually responding fine, but it's communicating with other teams or with customers about what's going on. And so having a language around the implications and the severity and so on and so forth is super important. And you ask these things in part of your process. We'll talk about this in a little bit, but did you feel during this incident response that you actually notified the right stakeholders, or that you notified them at the right time? And what about the customers? So finally, thinking about, okay, we had an incident. Well, what was the promise that was actually broken here that led to this incident? So thinking about these things will really help.
There's another old saying that I really enjoy, which is that creativity is the art of masking your sources. There's nothing wrong to looking to the outside world for sources of inspiration. In the 90s, we called this thinking outside the box, which is, of course, today a much lampooned expression. But the essential truth of both of these statements remains, right? You can learn from what other people have done, okay? We're talking about communication, we're talking about how to communicate, learning how to communicate. We can look to the military, for example, right? The military, any military around the world, has actually spent an enormous amount of time and effort and frankly just shared experience putting together a language that to the casual observer on the outside just seems like an endless stream of gibberish, right? It's acronyms and made up words and words with different definitions and like, why are they speaking this way? Why can't they just use English or French or Spanish or whatever local language, right? Well, there's a good reason for it. The reason they spend so much time developing their own language is because it's a way to very efficiently and very quickly transmit incredibly dense domain-specific information in a way that doesn't invite ambiguity. And that's incredibly powerful. When you can have a really solid assurance that whoever it is you're speaking to understands exactly what it is that you're saying, and you can do that quickly, that's incredible, right? But building that out takes time, and it takes effort. And once you started to build it out, you have to get everybody on board and doing it, and that means you have to practice. You have to practice communicating. I know that sounds sort of ridiculous, but it's absolutely the case. You need to practice how to communicate with one another. And if you're practicing at something, the idea is you're getting better at it, right? The first step to getting good at something is sucking at something. The idea is you improve. And in order to improve, or to know that you've improved, you have to measure.
That's right. As we said earlier with the first key insight of SRE, one of the key insights is measuring not just machine systems, but also human and organizational systems. And so one of the most important reliability-related organization systems is your incident response process. So how do you measure a particular incident response? How do you say, objectively, did we respond to this incident well or poorly? You've been up all night dealing with some fire. Maybe it feels like it went terribly, or maybe it feels like it actually went really well. How do you quantify this, and how do you think about it objectively? Well, we started a few things. There's two categories of things that we try to capture here. So one are quantitative metrics associated with an incident response. So these are things generally related to time. For example, you have time to detect. How long did it take you to notice this particular incident? Time to engage. How long did it take to get the right people working on this incident? Time to fix. How long did it take once people were actually engaged on this to solve the incident? So these are very quantifiable. Very quantifiable. You can trend them over time. What about some of the more qualitative things? So what about communications? So for example, you might find, as I mentioned earlier, that in fact your time to fix was fine. You know, your time to detect was fine. You have automated monitoring. But the problem is that people aren't communicating. They're not notifying the right people. And then you can start to ask questions, well, why? You know, is it clear who we need to communicate with? Do we have all of the stakeholders actually recorded somewhere? And maybe that's something we can improve on. So doing this stuff, it can really help, you know, in improving your incident response process. And you might see different areas within the organization that need help in different areas, right? So you might see that one particular part is great at auto detection. All of their monitoring is fantastic. And you might find another area is poor in auto detection, but they're actually great in communications. So doing this trending over time can help you with that feedback loop and that continuous improvement cycle which we've been talking about.
Super, super critical. All right. My last great expression for the day that I'm going to share with you. All good things must come to an end. And this was a pretty good presentation, so it does have to end. So here we go. Let's recap. Why SRE, right? That's the first question you're going to have to answer. You're going to walk out of here, you go, Niall and Dan, we're convinced we need to do SRE or we need to start implementing some of these principles. The very first thing to do is answer this question of why. That gets you the buy-in. The next thing is to get your instrumentation on point. Keep it simple to start, right? The 4 golden signals, get that spreadsheet action going on. Next, enumerate your promises. And this can be fun. Make a game day out of it. It's a great opportunity to drag all the skeletons out of the closet. Fair enough? And finally, measure your response when promises are broken. That's super, super important. Get your post-mortem game on point. Super critical.
So I can share a few things at the end, having gone through some of this process at Coinbase, at our organization. So what have we actually gotten out of this process, this journey that we've described? So I think the first thing that we've gotten is by instrumenting everything, systems that were previously opaque are now transparent. So we can see the inner workings, what's going on here in terms of reliability and in different areas. We've gotten that transparency. And that transparency leads to a better understanding. So now we can understand like why a particular system might have a bottleneck in some area, or maybe we need to invest in some other tech debt that needs to be solved that we've seen through instrumentation. All of this together, I think, really increases our confidence in our ability to respond to incidents, to reliability fixes on an ongoing basis with a lot more confidence. So ultimately, the outcome of all this is increased confidence in your reliability.
That's the best one for me, frankly. I mean, transparency and understanding are critical, but being able to gain that confidence and being able to express that trust in quantifiable ways, I mean, you can't put a value on that, which is good because SRE is kind of a big deal. It's going to cost you some money. But that's huge, right? Being able to gain that confidence and that trust, amazing, absolutely amazing. All right, so before we go, a couple items.
So I'm Niall. Great to speak with you all. I'm from Coinbase. And if you would like to talk more, we are having a happy hour event tomorrow evening.
Crypto happy hour.
Crypto happy hour. It's after our Crypto 101 here at the area in the Startup Central area tomorrow from 5 to 6. So please come along. Love to chat there.
Yeah, I think I'm going to come through on that, actually.
You should.
Yeah, I think that sounds good. For my part, my name's Daniel. Again, I work for a company called Datadog. If you'd like to chat about anything about this or crypto, we've got a bunch of crypto nerds at our booth over at the Venetian, actually, so feel free to come chat. There's some drops on your chairs for cleaning your glasses. So if you have glasses or a loved one who has glasses, feel free to take one of those little glasses cleaners. Also, we are doing a game day on Wednesday, so that's tomorrow, So feel free to come to the AWS Game Day. Lots of fun, fabulous prizes. Hope to see you out. Thank you very much, everybody.